CIET NCERT presents Audiobook of Science for Class 7 entitled Science. This is Lesson 15 from page 174 to page 192. Let's listen to the Lesson 15. Light. Page 174. You might have observed a beam of sunlight when it enters a room through a narrow opening or a hole. You might have also observed beams of light from the headlamps of scooters, cars, and engines of trains. You can observe this in figure 15.1a. Similarly, a beam of light can be observed from a torch. Some of you may have observed a beam of searchlight from a lighthouse or from an airport tower. You can observe this in figure 15.1b. What do these experiences suggest? Figure 15.1a. Rail engine. B. Lighthouse. 15.1.
Light travels along a straight line.
Bojo recalls an activity he performed in class 6. In that activity, he observed a lighted candle first through a straight pipe and then through a bent pipe. You can observe this in figure 15.2. Why was the candle flame not visible to Bojo through a bent pipe? Figure 15.2, looking at a candle through a straight pipe and a bent pipe. Page 175. This activity showed that light travels along straight lines. How can we change the path of light? Do you know what happens when light falls on a polished or a shiny surface? 15.2. Reflection of light. One way to change the direction of light is to let it fall on a shiny surface. For example, a shining stainless steel plate or a shining steel spoon can change the direction of light. The surface of water can also act like a mirror and change the path of light. Have you ever observed the reflection of trees or buildings in water? You can observe this in figure 15.3. Figure 15.3. Reflection of objects in water. Here we have a pond. Next to pond are some trees. The reflection of trees can be observed on the surface of pond. Any polished or a shiny surface can act as a mirror. What happens when light falls on a mirror? You have learned in class 6th that a mirror changes the direction of light that falls on it. This change of direction by a mirror is called reflection of light. Can you recall the activity in which you got the light of a torch reflected from a mirror? Let us perform a similar activity. Paheli remembers the story of the lion and the rabbit from the Panchtantra, in which the rabbit fooled the lion by showing him his reflection in water. You can observe this in figure 15.4. Figure 15.4. Reflection of the lion in water. Activity 15.1. Take a torch. Cover its glass with a chart paper which has 3 narrow slits, as you can observe in figure 15.5. Spread a sheet of chart paper on a smooth wooden board. Page 176. Fix a plain mirror strip vertically on the chart paper, as you can observe in figure 15.5. Now, direct the beam of light on the mirror from the torch with slits. Place the torch in such a way that its light is observed along the chart paper on the board. Now adjust its position so that the light from the torch strikes the plane mirror at an angle. You can observe this in figure 15.5. Figure 15.5, reflections of light from a mirror. Here we can observe the torch with slits of chart paper pasted on it, reflecting light from a mirror. The beam of light seems to have been divided in parts. Does the mirror change the direction of the light that falls on it? Now move the torch slightly to either side. Do you find any change in the direction of reflected light? Observe the mirror along the direction of the reflected light. Do you observe the slits in the mirror? This is the image of the slits. This activity tells us how light gets reflected from a plane mirror. Let us play around with the images formed in mirrors and know a little more about them. There's a thought bubble given here. A picture of Paheli is next to it. Paheli wants to know what makes things visible to us. Bojo thinks that objects are visible only when the light reflected from them reaches our eyes. Do you agree with him? Activity 15.2. Caution. Handle the lighted candle with care. It is better if this activity is performed in the presence of a teacher or an elder person. Place a lighted candle in front of a plane mirror. Try to observe the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. You can observe this in figure 15.6. The candle itself is the object. Now move the candle to different positions in front of the mirror. Observe the image in each case. Figure 15.6, image of a candle in a plane mirror. Page 177. There's a thought bubble given here. A picture of Bojo is next to it. Bojo noted in his notebook, "Is it not surprising that my image is of the same size as me, whether the mirror is small or large?" Was the image upright in each case? Did the flame appear on top of the candle as in the object? Such an image is called erect. An image formed by a plane mirror is erect and the same size as the object. Now place a vertical screen behind the mirror. Try to obtain the image of the candle on this screen. Can you get the image on the screen? Now place the screen in front of the mirror. Can you get the image on the screen now? You will find that image of the candle cannot be obtained on the screen in either case. What about the distance of the image from mirror? Let us perform another activity. Activity 15.3. Take a chessboard. If a chessboard is not available, draw on a chart paper 64, which is 8 by 8, squares of equal size. Draw a thick line in the middle of the paper. Fix a plane mirror vertically on this line. Place any small object, such as a pencil sharpener, at the boundary of the third square counting from the mirror. You can observe this in figure 15.7. Note the position of the image. Now shift the object to the boundary of the fourth square. Again, note the position of the image. Did you find any relation between the distance of the image from the mirror and that of the object in front of it? You will find that the image is at the same distance behind the mirror as the object is in front of it. Now verify this by placing the object anywhere on the chart paper. Figure 15.7, locating image in a plane mirror. Here, we are conducting the experiment with a mirror, a pencil sharpener, and a chessboard. There's a thought bubble given here. A picture of Paheli is next to it. Paheli made a note in her notebook. In a plane mirror, the image is formed behind the mirror. It is erect, of the same size, and is at the same distance from the mirror as the object is in front of it. Page 178. 15.3. Right or left? When you see your image in a plane mirror, is it exactly like you? Have you ever noticed that there is one interesting difference between you and your image in a mirror? Let us find out. Activity 15.4. Stand in front of a plane mirror and look at your image. Raise your left hand. Which hand does your image raise? You can observe this in figure 15.8. Now, touch your right ear. Which ear does your hand touch in your image? Observe carefully. You will find that in the mirror, the right appears left and the left appears right. Note that only sides are interchanged. The image does not appear upside down. Now, write down your name on a piece of paper and hold it in front of a plane mirror. How does it appear in the mirror? Figure 15.8. Left hand appears on the right side in the image. Here we can observe a boy raising his left hand. It appears on the right side in the image on the mirror. There's a thought bubble given here. Bojo saw an ambulance on the road. He was surprised to see that the word ambulance in front was written in a strange manner. Can you now understand why the word ambulance is written as in figure 15.9? When the driver of a vehicle ahead of an ambulance looks in her or his rearview mirror, she or he can read ambulance written on it and give way to it. It is the duty of every one of us to allow an ambulance to pass without blocking its way. You might have observed that in the side mirror of a scooter or a car, the images of all objects appear smaller than the objects themselves. Have you ever wondered why is it so? Figure 15.9. An ambulance. Here, the word ambulance has been written in such a way that it can be read correctly in the mirror image. Page 179. 15.4. Playing with spherical mirrors. Paheli and Bojo were waiting for their dinner. Bojo lifted a stainless steel plate and saw his image in it. Oh, this plate acts as a plane mirror. My image is erect and is on the same size. Paheli saw her image using the back of a steel spoon. Bojo, look here. I can also see my erect image, though it is smaller in size. The spoon also acts as a mirror of some kind, said Paheli. You can also use a spoon or any curved shining surface to observe your image. Activity 15.5. Take a stainless steel spoon. Bring the outer side of the spoon near your face and look into it. Do you observe your image in it? You can observe this in figure 15.10. Is this image different from what you see in a plane mirror? Is this image erect? Is this image of the same size, smaller or larger? Now, observe your image using the inner side of the spoon. This time, you may find that your image is erect and larger in size. If you increase the distance of the spoon from your face, you may observe your image to be inverted. You can observe this in figure 15.11. You can also compare the image of your pen or pencil instead of your face. Figure 15.10. Image from the outer side of a spoon. Figure 15.11. Image from the inner side of a spoon. The curved, shining surface of a spoon acts as a mirror. The most common example of a curved mirror is a spherical mirror. If the reflecting surface of a spherical mirror is concave, it is called a concave mirror. If the reflecting surface is convex, then it is a convex mirror. You can observe this in figure 15.12. 15.12. A concave, and B. A convex mirror. Page 180. Why are concave and convex mirrors called spherical mirrors? Take a rubber ball and cut a portion of it with a knife or a hacksaw blade. You can observe this in figure 15.13a. Be careful. Ask an elder person to help you in cutting the ball. The inner surface of the cut ball is called concave and the outer surface is called convex. You can observe this in figure 15.13b. 15.13. A spherical mirror is a part of a sphere. Here we can observe someone cutting a ball. After the ball is cut, the inner side of the ball is the concave surface and the outer side of the ball is convex surface. The inner surface of a spoon acts like a concave mirror while its outer surface acts like a convex mirror. We know that the image of an object formed by a plane mirror cannot be obtained on a screen. Let us investigate if it is also true for the image formed by a concave mirror. Activity 15.6. Caution! You will conduct activity 15.6 in the sunlight. Be careful. Never look directly towards the sun or its image as it may damage your eyes. You may look at the image of the sun when it is thrown on a screen or a wall. Take a concave mirror. Hold it facing the sun. Try to get the light reflected by the mirror on a sheet of paper. Adjust the distance of the paper until you get a sharp, bright spot on it. You can observe this in figure 15.14. Hold the mirror and the sheet of paper steady for a few minutes. Does the paper start burning? This bright spot is in fact the image of the sun. Notice that this image is formed on a screen. An image formed on a screen is called a real image. Recollect that in activity 15.2, the image formed by a plane mirror could not be obtained on a screen. Such an image is called a virtual image. Figure 15.14. A concave mirror forms a real image of the sun. Here, we can observe the image of a sun on a sheet of paper. This has been done by reflecting it with the help of a mirror. Now, let us try to obtain on the screen the image of a candle flame formed by a concave mirror. Activity 15.7. Fix a concave mirror on a stand. Any arrangement to keep the mirror steady would do. And place it on a table. You can observe this in figure 15.15. Paste a piece of white paper on a cardboard sheet, which is say about 15 cm into 10 cm. Page 181. This will act as a screen. Keep a lighted candle on the table at a distance of about 50 cm from the mirror. Try to obtain the image of the flame on the screen. For this, move the screen till a sharp image of the flame is obtained. Make sure that the screen does not obstruct the light from the candle falling on the mirror. Is this image real or virtual? Is it of the same size as the flame? Now, move the candle towards the mirror and place it at different distances from it. In each case, try to obtain the image on the screen. Record your observations in Table 15.1. Is it possible to obtain the image on the screen when the candle is too close to the mirror? You can observe this in Figure 15.16. We observe that the image formed by a concave mirror can be smaller or larger in size than the object. The image may also be real or virtual. Concave mirrors are used for many purposes. You might have observed doctors using concave mirrors for examining eyes, ears, nose, and throat. Concave mirrors are also used by dentists to observe an enlarged image of the teeth. You can observe this in Figure 15.17. The reflectors of torches, headlights of cars, and scooters are concave in shape. You can observe them in Figure 15.18. Figure 15.15. Real images formed by a concave mirror. We can observe that the images formed are not of the same size as the object. Figure 15.16. Virtual image formed by a concave mirror. Here, we can observe that the candle has been kept very close to the mirror. The flame of the candle can be observed in the mirror. Page 182. Figure 15.17. A dentist examining a patient. Bojo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and smaller in size. He wondered if the bell is also a kind of spherical mirror. Can you recognize the type of the mirror? Note that the reflecting surface of the bell is convex. Figure 15.18. Reflector of a torch. Here, we can observe the concave surface of the reflector of a torch. Table 15.1. Image formed by a concave mirror for object placed at different distances from it. Here, we have a table with 3 columns and 6 rows. In the first column, we have distance of the object from the mirror. In the second column, we have to tell whether it is smaller or larger than the object. In the third column, we have the character of the image. We have to fill in whether it is inverted or erect, and also whether it is real or virtual. Distance of the object from the mirror: 50 cm, 40 cm, 30 cm, 20 cm, 10 cm, 5 cm. Activity 15.8. Repeat activity 15.7 now with a convex mirror in place of a concave mirror. You can observe this in Figure 15.19. Record your observations in a table similar to Table 15.1. Figure 15.19. Image formed by a convex mirror. Could you get a real image at any distance of the object from the convex mirror? Did you get an image larger in size than the object?
Page 183.
Can you now recognize the mirrors used as side mirrors in automobiles? These are convex mirrors. Convex mirrors can form images of objects spread over a large area. So, these help the drivers to see the traffic behind them. You can observe this in figure 15.20. Figure 15.20, convex mirror as side view mirror. 15.5, images formed by lenses. You might have observed a magnifying glass. It is used to read very small print. You can observe this in figure 15.21. You might have also used it to observe the body parts of a cockroach or an earthworm. The magnifying glass is actually a type of a lens. Lenses are widely used in spectacles, telescopes, and microscopes. Try to add a few more uses of lenses to this list. Get some lenses. Touch and feel them. Can you find some difference just by touching? Those lenses which feel thicker in the middle than at the edges are convex lenses. You can observe that in figure 15.22a. Those which feel thinner in the middle than at the edges are concave lenses. You can observe this in figure 15.22b. Notice that the lenses are transparent and light can pass through them. Figure 15.21, a magnifying glass. Figure 15.22, a convex lens, and B, a concave lens. We can observe that the convex lens is thicker in the middle and the concave lens is thinner in the middle. Let us play with lenses. Caution! It is dangerous to look through the lens at the sun or a bright light. You should also be careful not to focus sunlight with a convex lens on any part of your body. Page 184. Activity 15.9. Take a convex lens or magnifying glass. Put it in the path of sun rays. Place a sheet of paper as you can observe in figure 15.23. Adjust the distance between the lens and the paper till you get a bright spot on the paper. Hold the lens and the paper in this position for a few minutes. Does the paper begin to burn? Now, replace the convex lens with a concave lens. Do you see a bright spot on the paper this time too? Why are you not getting a bright spot this time? We have seen in the case of mirrors that for different positions of the object, the nature and size of the image change. Is it true for lenses also? Let us find out. Figure 15.23, real image of the sun by a convex lens. Here we can observe a small image of the sun on the paper which is being reflected with the help of the lens. Activity 15.10. Take a convex lens and fix it on a stand as you did with the concave mirror. Place it on a table. Place a lighted candle at a distance of about 50 cm from the lens. You can observe this in figure 15.25a. Try to obtain the image of the candle on a paper screen placed on the other side of the lens. You may have to move the screen towards or away from the lens to get a sharp image of the flame. What kind of image did you get? Is it real or virtual? Note: a convex lens converges or bends inward, the light generally falling on it. You can observe this in figure 15.24a. Therefore, it is called a converging lens. On the other hand, a concave lens diverges or bends outward the light, and it is called a diverging lens. You can observe this in figure 15.24b. Figure lens converges sharp image of the flame. What kind of image did you get? Is it real or virtual? Note: a convex lens converges or bends inward, the light generally falling on it. You can observe this in figure 15.24a. Therefore, it is called a converging lens. On the other hand, a concave lens diverges or bends outward the light, and it is called a diverging lens. You can observe this in figure 15.24b. Figure 15.24. A. Here we can see the light converging as it is passing through a convex lens. B. Here we can observe the light to diverge as it passes through a concave lens. Now vary the distance of the candle from the lens. You can observe this in figure 15.25b. Try to obtain the image of the candle flame every time on the paper screen by moving it. Record your observations as you did in activity 15.7 for the concave mirror. There's a thought bubble given here. A picture of Bojo is next to it. He is wondering. It means that we can see the image formed by a lens from the side opposite to that of the object. Page 185. Did you get in any position of the object an image which was erect and magnified? You can observe this in figure 15.26. Could this image be obtained on a screen? Is the image real or virtual? This is how a convex lens is used as a magnifying glass. In a similar fashion, study the images formed by a concave lens. You will find that the image formed by a concave lens is always virtual, erect, and smaller in size than the object. You can observe this in figure 15.27. Figure 15.25. Image by a convex lens for object placed at different distances from it. In the first picture, the image formed appears to be small in size. When the candle is brought close to the lens, the image seems to be magnified. Figure 15.26. Virtual image formed by the convex lens. Here, we can observe a magnified image. Figure 15.27. Image formed by a concave lens. Here, we can observe a smaller image. 15.6. Sunlight, white or colored. Have you ever observed a rainbow in the sky? You might have noticed that it appears usually after the rain when the sun is low in the sky. The rainbow can be observed as a large arc in the sky with many colors. You can observe it in figure 15.28. Figure 15.28, a rainbow.
Page 186.
How many colors are present in a rainbow? When observed carefully, there are 7 colors in a rainbow, though it may not be easy to distinguish all of them. These are red, orange, yellow, green, blue, indigo, and violet. There's a thought bubble given here. A picture of Paheli is next to it. Does this mean that the white light consists of 7 colors? You might have observed that when you blow soap bubbles, they appear colorful. Similarly, when light is reflected from the surface of a compact disc or CD, you observe many colors. You can observe this in figure 15.29. Figure 15.29, a CD placed in sun. We can observe the colors of a rainbow on the surface of the CD. On the basis of these experiences, could we say that the sunlight is a mixture of different colors? Let us investigate. Activity 15.11. Take a glass prism. allow a narrow beam of sunlight through a small hole in the window of a dark room to fall on one face of the prism. Let the light coming out of the other face of the prism fall on a white sheet of paper or on a white wall. Figure 15.30. A prism splits a beam of sunlight into 7 colors. There's a thought bubble given here. A picture of Paheli is next to it. Paheli wants to tell you that you can observe a rainbow only when your back is towards the sun. Page 187. Do you observe colors similar to those in a rainbow? You can observe this in figure 15.30. This tells us that the sunlight consists of 7 colors. The sunlight is said to be white light. This means that the white light consists of 7 colors. Try to identify these colors and write their names in your notebook. Can we mix these colors to get white light? Let us try. Activity 15.12. Take a circular cardboard disc of about 10 cm diameter. Divide this disc into 7 segments. Paint the 7 rainbow colors on these segments as you can observe in figure 15.31a. You can also paste colored papers on these segments. Make a small hole at the center of the disc. Fix the disc loosely on the tip of a refill of a ball pen. Ensure that the disc rotates freely. You can observe this in figure 15.31a. Rotate the disc in the daylight. When the disc is rotated fast, the colors get mixed together and the disc appears to be whitish. You can observe this in figure 15.31b. Such a disc is popularly known as Newton's disc. Figure 15.31a. A disc with 7 colors. B. It appears white on rotating. Paheli has a brilliant idea. She has prepared a small top with a small circular disc with 7 rainbow colors painted on it. You can observe this in figure 15.32. When the top rotates, it appears nearly white. Figure 15.32. A top with 7 colors. When it rotates, it appears to be white. Page 188. Keywords. Concave lens, concave mirror, convex lens, convex mirror, erect image, magnified image, magnifying glass, prism, rainbow, real image, rear view mirror, side mirror, spherical mirror, virtual image. What you have learned. 1. Light travels along straight lines. 2. Any polished or a shining surface acts as a mirror. 3. An image which can be obtained on a screen is called a real image. 4. An image which cannot be obtained on a screen is called a virtual image. 5. The image formed by a plane mirror is erect. It is virtual and is of the same size as the object. The image is at the same distance behind the mirror as the object is in front of it. 6. In an image formed by a mirror, the left side of the object is seen on the right side in the image, and right side of the object appears to be on the left side in the image. 7. A concave mirror can form a real and inverted image when the object is placed very close to the mirror, the image formed is virtual, erect, and magnified. 8. Image formed by a convex mirror is erect, virtual, and smaller in size than the object. 9. A convex lens can form real and inverted image. When the object is placed very close to the lens, the image formed is virtual, erect, and magnified. When used to see objects magnified, the convex lens is called a magnifying glass. 10. A concave lens forms erect, virtual, and smaller image than the object. 11. White light is composed of 7 colors. Page 189. Exercises. 1. Fill in the blanks. A. An image that cannot be obtained on a screen is called blank. B. Image formed by a convex blank is always virtual and smaller in size. C. An image formed by a blank mirror is always of the same size as that of the object. D. An image which can be obtained on a screen is called a blank image. E. An image formed by a concave blank cannot be obtained on a screen. 2. Mark T if the statement is true and F if it is false. A. We can obtain an enlarged and erect image by a convex mirror. B. A concave lens always forms a virtual image. C. We can obtain a real, enlarged, and inverted image by a concave mirror. D. A real image cannot be obtained on a screen. E. A concave mirror always forms a real image. 3. Match the items given in column 1 with one or more items of column 2. Column 1. A. A plane mirror. B. A convex mirror. C. A convex lens. D. A concave mirror. E. A concave lens. Column 2. 1. Used as a magnifying glass. 2. Can form image of objects spread over a large area. 3. Used by dentists to see enlarged image of teeth. 4. The image is always inverted and magnified. 5. The image is erect and of the same size as the object. 6. The image is erect and smaller in size than the object. 4. State the characteristics of the image formed by a plane mirror. 5. Find out the letters of English alphabet or any other language known to you in which the image formed in a plane mirror appears exactly like the letter itself. Discuss your findings. Page 190. 6. What is a virtual image? Give one situation where a virtual image is formed. 7. State two differences between a convex and a concave lens. 8. Give one use each of a concave and a convex mirror. 9. Which type of mirror can form a real image? 10. Which type of lens forms always a virtual image? Choose the correct option in questions 11 to 13. 11. A virtual image larger than the object can be produced by a 1. Concave lens. 2. Concave mirror. 3. Convex mirror. 4. Plane mirror. 12. David is observing his image in a plane mirror. The distance between the mirror and his image is 4 meters. If he moves 1 meter towards the mirror, then the distance between David and his image will be 1. 3 meters, 2. 5 meters, 3. 6 meters, 4. 8 meters. 13. The rear view mirror of a car is a plane mirror. A driver is reversing his car at a speed of 2 meters per second. The driver sees in his rear view mirror the image of a truck parked behind his car. The speed at which the image of the truck appears to approach the driver will be 1. 1 meter per second, 2. 2 meters per second, 3. 4 meters per second, 4. 8 meters per second. Extended learning activities and projects. 1. Play with a mirror. Write your name with a sketch pen on a thin sheet of paper, polythene or glass. Read your name on the sheet while standing in front of a plane mirror. Now, observe your image in the mirror. 2. A burning candle in water. Take a shoe box. Open on one side. Place a small lighted candle in it. Place a clear glass sheet, roughly 25 cm into 25 cm, in front of this candle. You can observe this in figure 15.33. Try to locate the image of the candle behind the glass sheet. Place a glass of water at its position. Ask your friends to look at the image of the candle through the sheet of glass. Ensure that the candle is not visible to your friends. Your friends will be surprised to observe the candle burning in water. Try to explain the reason. Figure 15.33. Candle burning in water. Here, we can observe a boy conducting the experiment which makes the candle to appear burning in water. Page 191. 3. Make a rainbow. Try to make your own rainbow. You can try this project in the morning or in the evening. Stand with your back towards the sun. Take a horse pipe or a water pipe used in the garden. Make a fine spray in front of you. You can observe different colors of rainbow in the spray. 4. Visit a laughing gallery in some science center or a science park or a village mela. You will find some large mirrors there. You can observe your distorted and funny images in these mirrors. Try to find out the kind of mirrors used there. 5. Visit a nearby hospital. You can also visit the clinic of an ENT specialist or a dentist. Request the doctor to show you the mirrors used for examining ear, nose, throat, and teeth. Can you recognize the kind of mirror used in these instruments? 6. Role play. Here is a game that a group of children can play. One child will be chosen to act as object and another will act as the image of the object. The object and the image will sit opposite to each other. The object will make movements such as raising a hand, touching an ear, etc. The image will have to make the correct movement following the movement of the object. The rest of the group will watch the movements of the image. If the image fails to make the correct movement, she or he will be retired. Another child will take her or his place, and the game will continue. A scoring scheme can be introduced. The group that scores the maximum will be declared the winner. Page 192. Did you know? The mirrors can be used as weapons. Archimedes, a Greek scientist, is said to have done just that more than 2000 years ago. When the Romans attacked Syracuse, a coastal city-state in Greece, Archimedes used mirrors arranged as in figure 15.34. The mirrors could be moved in any direction. They were positioned such that they reflected the sunlight on the Roman soldiers. The soldiers were dazzled by the sunlight. They did not know what was happening. They got confused and ran away. This was an example of triumph of ideas over military might. Archimedes' mirrors. Here we can observe a beach. Mirrors have been placed on the shore. The mirrors are reflecting the light of the sun towards a boat. The chapter 15 of total 18 chapters of the book ends here.